Hi guys, I will be back soon. I thought I'd be back before the bell, but I was not, obviously. I will go over questions for the homework after notes, and like I said, I should be back sometime during the notes. So here we go. They are your own notes. Day 4, section R.6, and it's just more on exponents. Today's notes aren't bad at all. Feel free, once I put up a problem, to pause it and work through it. I'm not going to take those needed pauses like I normally would, but whoever is airplaying this for me, feel free to just go ahead and hit pause if you want for each one. And number 1, find the product. Find the product. Can't talk. (3x to the 1/3) times. Okay, our directions will be to simplify for the rest. Okay, number 3. 4 to the 1/3 over 500 to the 1/3. If I was in class, I'd be asking a bunch of questions like, hey, 4 cannot be broken down anything to the third as well as 500. And I'd be giving you time to hopefully look for something, and you can feel free to pause, but what we notice here is that these are both being raised to the 1/3 power. Therefore, I could just rewrite it as 4 over 500 to the 1/3. And the purpose of that is to reduce that 4 over 500, 1 over 125 now, to the 1/3. And 125 is better for me. That's really 1/5 all cubed raised to the 1/3. 1/3 of 3 is 1, and we're left with our answer of 1/5. Same idea for this one, 90 to the 2/3 times 0.3 to the 2/3. And once again, notice that 2/3 and 2/3, because 90 and 0.3 don't break down in the way that I would like them to. Therefore, I can rewrite it as 90 times 0.3 all to the 2/3. 90 times 0.3 is not 90 times a third. I've seen it before. It's 90 times 3/10 to the 2/3. 10 divides into 99 times 3 is 27 to the 2/3. 3 cubed to the 2/3 is 3 squared, or our 9. Feel free to pause if I'm going too fast. Okay, we're going to go back to our complex fractions. Just remember, from things we talked about last chapter as well, that x plus y all to the negative first is not equivalent to x to the negative first plus y to the negative first. Okay, x, y all to the negative first divided by x to the negative first plus y to the negative first. Okay, first thing we need to do is get rid of those negative exponents. Therefore, I'm going to rewrite this as 1 over xy all divided by 1 over x plus 1 over y. Now we're back to complex fractions like we dealt with on day 2. The LCD of the problem is xy, therefore I'm going to multiply by xy in the numerator and xy in the denominator. And 1 over xy times xy simplifies to 1. 1 over x times xy, the x's cancel out, we're left with y, plus 1 over y times xy leaves us just with x. And we get our final answer of 1 all divided by y plus x. Okay, number 6. A to the negative first b minus a b to the negative first all over 1 over a plus 1 over b. Okay, this is where I've seen lots of mistakes. A to the negative first b is a to the negative first b to the first. Oops, I'm going to make that red. And that's a to the first, b to the negative first. Both variables do not need to move. Therefore, when I rewrite this, it will be b over a minus a over b. I cannot tell you the number of times that I see students move both of them just because they see the negative, but you have to look at where that negative is connected to. So I'm just going to rewrite the rest of it, and then now very similar to the last one, we have an LCD of a b and b over a times ab is b squared minus a over b times ab is a squared all over b plus a. But we're not done. Hopefully you see that b squared minus a squared is the difference of squares. B minus a, b plus a, all divided by that b plus a, allows us to reduce out the b plus a and we're left with our final answer of b minus a. Okay, last one, and there's many ways of going about this problem. Keep that in mind. The quantity ab to the negative first plus b to the negative first all to the negative first. So do not distribute that negative 1. Okay? I'll show you 2 different methods. Okay, first method is to deal with that outermost negative 1. Then I get 1 over ab all to the negative first plus b to the negative first. So it's getting rid of that outside negative 1, which then can be rewritten as over 1 over ab plus 1 over b. We now have that LCD of ab. Have to do the same thing to the numerator and the denominator. And we're left with ab over 1 plus a. And done. Method 2 is a little bit more of, using order of operations. Innermost parentheses gives us, let's see, 1 over ab plus 1 over b, all to the negative first. You could go and now really transform it back into, here. Or some people like to now get a common denominator. So they're going to multiply this by a over a. So it's a little different. It's not our complex fraction per se. And we'll have 1 plus a over ab raised all to the negative first. And since it's a fraction raised to a negative, we just flip it and get ab over 1 plus a, and we are done.